These are notes for Algebra 2, Section 8.2. We're going to be graphing rational functions. Let's first look at the parent function for a rational function. As you can see, this is the parent function here. We have these two curved lines on either side of the x and y axis. This shape, the graph of the parent rational function, is called a hyperbola. That's big fancy word for this particular shape. The two branches on either side of the graph, in quadrant 1 and in quadrant 3, these two branches are symmetrical, so they are mirror images of each other along a particular line that slants through. We, of course, have a domain and range, and for the parent function, the domain and range are all non-zero real numbers. Now, the domain does not contain 0 because we have a vertical asymptote at x equals 0. So we have this domain of x equals 0, or x equals every number except x equals 0, I should say, because the graph, as you can see, gets closer to x equals 0, but it never actually touches it. The same is true for the for a horizontal asymptote. You can see one that is along the x-axis. That horizontal asymptote is also never touched by the graph. So the range doesn't contain 0 either. So we'd say that the domain and range are all non-zero real numbers. Or we could say that they are all real numbers except 0. These asymptotes, as I've said, are x and x equals 0 and y equals 0. And graphing rational functions is mostly about finding the asymptotes. That is probably the trickiest part of the whole thing. Find the asymptotes and you are good to go. So let's look at this in a little bit more detail. This is the graph of f of x equals 1 over x. But it could just as easily be f of x equals 3 over x or 4 over x. In fact, any function that's just some number a over x has this shape. And the asymptotes are the same. And if the asymptotes are the same, that means the domain and range are all the same. So that's kind of nice. Regardless of what this number is here, whatever a is, 4, 5, 6, 7, 8, 9, 10, whatever, the asymptote, domain, and range will always be the same. Let's actually graph one of these. Now we're going to graph the function y equals 4 over x. So this is in that form of a over x. A is 4. So that means that our asymptotes are going to be at x equals 0 and y equals 0. Same as the parent function. And I'm going to go ahead and draw those in. Let me get some, make my line a little bit thinner here. So I'm going to go ahead and draw these guys in. There's my vertical asymptote. There's my horizontal asymptote. Now, as I said, the trickiest part of this whole thing is finding the asymptotes. All right, we've already done that, so yay! We've got a little bit of an easier job ahead of us. Because the next thing we have to do is real simple. We plug 4 over x into the graphing calculator, and we look at the table. So we go to so we plug it into y equals. We hit second graph. and we find some points. And the points we're looking for are whole numbers. Right? We want points that are easy to plot. So we're going to look for some whole number values here. For instance, when x is negative 2, y is also negative 2. So that's a point for us. When x is negative 1, y is negative 4. And keep in mind, I'm reading all of these off the table. In fact, I'm going to put that on here. Get values from the table. Put a big star next to that to make it so we know that that's what we're supposed to be doing. When x is 1, y is 4. When x is 2, y is 2. So we've got some points. And we're going to plot those points to give us an idea of where this graph goes, because we need to know kind of where the graph is supposed to sit. So let's plot some points. We've got negative 2, that's a point right here. We've got negative 1, negative 4, that's a point down here. We've got 1, 4, that's a point way up here. And we've got a point 2, 2. So of course our graphs are going to be symmetrical branches on either side of this graph here, in quadrants 1 and 3. We want to draw the branches so that they pass through the plotted points and approach the asymptotes. So from here we're going to go up closer to the asymptotes, closer to the vertical asymptote, and then on the bottom, of course, closer to the lower asymptote. And we're going to do the same thing over here. There we go. Put a little arrow there. So there's our graph. Two asymptotes, right, at x equals 0, y equals 0, and two branches. Now, if we wanted to graph a translation, it's a very similar process. We need to find the asymptotes. Now, of course, if we are looking at this guy here, y equals a over x minus h plus k, it's not that bad. The the vertical asymptote is x equals h, right? Again, we group these guys together. And the vertical asymptote is y equals k. That shouldn't be too surprising. That looks pretty similar to things that we've done before. Then we want to plot points that are to the left and to the right of the asymptote. Then draw the two branches. I should have switched colors here, but who cares? So, we look at our graph, we say, okay, well, I've got x minus h over here plus k, so my so one asymptote is x equals h, one asymptote is y equals k. Let's plot some points. Now we've got negative 6 over x plus 3 plus 2. This is x minus h, and this is plus k. So h then is negative 3. So my asymptote here is at negative 3. My other asymptote, y equals 2, because k is 2. Another way to look at your asymptotes, at least the vertical asymptote, is to ask yourself what value of x will make the bottom of the fraction 0. If we know what value for x makes the bottom of the fraction 0, then we know what point on the graph can't exist. And that happens to be the asymptote, because the asymptote is the line where the graph doesn't exist. In this case, if x is negative 3, then negative 3 plus 3 is 0. So my vertical line would have to be at -3 to make that work. So we're going to plot some points. Again, we're going to go into our calculator to get this done. And when I plug this into the calculator, when x is -6, y is 4. When x is -4, y is 8. When x is -2, y is -4. And when x is 0, y is 0. So I just pull those numbers right out of the calculator. I'm going to start with my asymptotes. I have a vertical asymptote at x equals -3. So I'm going to start with that. -3 here is -2. We're counting by 2's. -2 is -3. So there we go. There's my asymptote there. My vertical or my horizontal asymptote is at y equals 2. So here's 2. Draw an asymptote there. And those are my two asymptotes. Right? X minus h plus k gives me my asymptotes. And like I said, that's really the hardest part. Let's plot some points. I've got -6, 4. So starting from my center, I've got -1, 2, 4, 6, and 2, 4. So I got a point right here. I've got -4, 8, 2, 4, 6, 8. I've got -2, -4, so way down here. I've got 0, 0. And I'm going to draw my branches here so that they approach my two asymptotes and go through my points. Notice that this time my graph is it sits in quadrant 2 and quadrant 4 as opposed to 1 and 3. That's because it was -6 on the top instead of +6. Had it been +6, it would have been flipped around the other way. Fortunately, the calculator will tell us that by telling us what points to plot. The next question we have to ask ourselves is, what are the domain and range? Well, the domain, as we can see, will go forever to -infinity, will go forever to +infinity. The only point it cannot be is -3, the vertical asymptote. So the domain is all real numbers except, that's a big except, -3. My range, similar idea. I can move upwards forever, I can move downwards forever, but I cannot touch the line y equals 2. So my range is all real numbers except 2.